Welcome to Vocabulary Video 4.1. This video is about collision theory and reaction rate. Reaction rate. The reaction rate or speed of reaction for a reactant or product in a particular reaction is defined as how fast or slow a reaction takes place. Example, if a reaction has a fast reaction rate, it will occur very quickly. If a reaction has a slow reaction rate, it will occur very slowly. In this picture, you can see one reaction rate being slower and one reaction rate being faster. Collision theory. This is the theory that explains how chemical reactions happen and what affects the speed of the reactions. Example, if you put more concentration of reactant together, raise the temperature, or add a catalyst, the reaction will happen faster. In this picture right here, we have low concentration resulting in few collisions and high concentration resulting in more collisions. This will lead to a faster reaction rate. Over here, we have a picture of temperature, concentration, and pressure increasing. That would be on the y-axis, and the rate of the reaction increasing as well on the x-axis. So this is a direct relationship. We will talk about this more in class. Activation energy. Activation energy is the minimum amount of energy that is required to start a chemical reaction. Example, without the correct amount of activation energy, a reaction will not occur. The activation energy is the difference that you see right here. So it's the difference between the reactant and the top of the hill, and we'll learn about these diagrams in class. And then the products occur only if there's enough activation energy present. So it's the amount of energy that it takes to start that chemical reaction. A catalyst. A catalyst is a substance that provides an alternative pathway for the reaction. It speeds up the chemical reaction by lowering the activation energy required. Examples: iron in the reaction to make ammonia, magnesium dioxide in the decomposition of hydrogen peroxide. So these are just two real examples of catalysts. If you look at this picture, this relates to activation energy as we just saw in the previous slide. When there is no catalyst, the activation energy required is very high. Remember that activation energy is needed to start the chemical reaction. If there's a catalyst present, the activation energy is actually lowered. So we actually need less activation energy to go ahead and start that reaction. This is going to speed it up and make it a little bit easier. Endothermic reaction. An endothermic reaction is a reaction that takes in energy or heat from the surroundings. Some examples are ice melting, food cooking or baking. In this picture we just have ice melting, so the heat's going in order to melt that ice. And then over here we have an energy diagram of an endothermic reaction, just like the ones we saw in the previous two slides. So this one requires a ton of activation energy. That's in the form of heat. So endothermic reactions do not occur unless the heat, which is the activation energy, is present. Lastly, we have an exothermic reaction. An exothermic reaction is the opposite of an endothermic reaction. It is a reaction that releases energy in the form of heat to the surroundings. Two examples are fire burning, like we see here, and a hot pack. In both of these examples, heat is given off to the surroundings. This is an energy diagram as we saw in the previous slides, and the difference in this one is that the hill is much smaller, so it takes much less activation energy, and that's because all of the energy is being given off.